Well, first of all, thank you so much for the invitation. What I wanted to do is to talk about a couple of things. So, given that also I'm the first talk of the conference, I wanted to have a brief introduction to Robo-advisors, at least for those people that may be listening in and they're not very familiar with the space. So at least they're trying to kind of motivate why this community is particularly interested in Robo-advice and Robo-advisors. I'm going to have a couple of slides on what I believe are the open questions in Robo-advising that I think people should be working on. And then I'm going to present this paper on algorithmic aversion and Robo-advice. But just to get started with what is Robo-advice, I mean, the way we think about Robo-advice is any advice that is generated by a computer algorithm that is tailored to clients' characteristics. And but I think one of the crucial aspects that many people sometimes forget, and that really seems to be the key element in terms of the efficacy of Robo-advice, is this automatic execution, right? There is a lot of papers in the finance literature showing that you can give individuals very good unbiased advice, but unfortunately it is rarely followed. So Bhattacharya et al. Have this kind of provocative paper where they write that you can lead a horse to water, but you can't make it drink. So the idea is that it is really the case that a key component of Robo-advice is this automatic execution. And we really kind of think about, at least in the finance and econ literature, we tend to think of Robo-advising as this kind of middle ground between having no intervention and having individuals make decisions on their own, and then the kind of libertarian paternalism of Richard Thaler and Cass Sunstein and the associated nudges. Now, why is Robo-advisors so important? Well, Robo-advisors is very important because we know that most investors are not financially savvy. We know that traditional advisors could help, but they have a number of drawbacks. They are very expensive. There's more and more evidence showing that they are rather ineffective. And in many cases, they can only cater and help wealthier individuals rather than the broader population. Now, Robo-advice can be extremely helpful because not only it has the scope to improve the effectiveness of financial advice, but it can also increase the number of people who can receive advice at reasonable costs. Now, the advantages of a robo-advisor then are usually that it can offer individuals financial advice for low fees. It can serve individuals with any level of wealth. And I think it also has this huge advantage of being able to be monitored and improved over time. And also from a regulatory perspective, you have that the functioning of robo-advisors in many cases can be explained to regulators and investors in a much simpler fashion compared to instead how individual financial advisors operate. Now, there are also some disadvantages, of course. Many individuals or clients are algorithmic aversion. I'm going to talk about it today in this paper. And many algorithms do not work very well. Now, one thing that I think it's absolutely crucial is to also highlight the fact that when we talk about robo-advisors, robo-advisors are coming very in different shapes and forms, right? So you have in general, we think that kind of robo-advisors differ along at least 4 dimensions. One is what we call the personalization of advice. And this is basically how many characteristics robo-advice is based on, right? So on the one extreme, I like to think about target date funds as the most primitive form of robo-advising, because the only characteristics that target date fund consider is or are the age of the investor. You also have that robo-advisors differ in the degree of involvement that the investors have in the financial plans and the choices. So in some cases, the robo-advisors propose some certain trades for the investors and that have to be approved. In some other cases, we have what we call robo-managers that in fact, where the investor chooses to sign up for a robo-advice, but then all the trades are done automatically on behalf of the investors. And there is also another difference between different types of robo-advice is that in some cases they leave investors the possibility to deviate from the suggestions or the recommendation in some other instead they do not allow any sort of deviation from the scheduled plan. And finally, I'm going to talk about it today, is that there is some forms of robo-advice involve human interactions. We call them hybrid robo-advisors, where you have that some kind of tasks of the robo-advising activity is delegated to the algorithms, and some instead are taken care by the human, or by a human, like usually it's a financial advisors. Now, but one thing that I would like you to think about is that the fact that whenever I talk about robo-advice, in particular in the US, people seem to be equating robo-advice with automated advice for portfolio allocation. When I talk about robo-advice, people think about Betterment, Wealth from Personal Capital, Vanguard, Schwab, Intelligent Portfolios, and so on and so forth. But if you think about it, households' decisions are way more complex than only financial assets decisions. So, of course, robo-advice is kind of commonly people refer to it as only that tool that helps individual making better investment decision. But if you think about households, and if you think households as a company, or you create a balance sheet of the households as much as companies do, they have assets and they have liabilities. And so, of course, within the assets, you're going to have the financial assets, which is what kind of Wealth from Betterment will take care for you. But you also have other assets, right? So households may have durable assets, so cars or housing. They may have, of course, human capital. But they will also have liabilities. So that would be the mortgages, or the credit card debts, or car payments, student loans, and so on and so forth. So the way we kind of think about robo-advice, I mean, is this idea of thinking about robo-advisors and any automated advice that helps individuals kind of take care of, make better decisions across all the different domains of their balance sheet. So in the liability side as well as the asset side. And if you're interested in this kind of work, like this is kind of more broadly my research agenda on robo-advice. I have a number of papers that are kind of analyzing this robo-advising for investment decisions. And then I also have a number of papers with my co-authors where we try to see how robo-advisors and fintech more generally can help individuals making better consumption, saving, debt, and lending decisions. And today I'm going to be presenting this paper. It's called Algorithmic Aversion, Theory and Evidence for Robo-advice, and I'm going to get to it in just a minute. One thing before getting into the paper is I just wanted to kind of mention what I think is going to be, or are going to be, the next step for robo-advice. I mean, there was Andy Lowe a couple years back had this very kind of provocative quote about robo-advisors. What it basically was arguing is that robo-advisors have great potential, but the technology is still immature. So he was arguing that they're the rotary phones to today's iPhones. That was like almost 4 or 5 years ago that he had this quote. And the idea, what he meant by this is that in many cases, kind of the robo-advice is rather fragmented, right? So we have a lot of companies that are helping people making better decisions on the consumption side, on the investment side, on the mortgage side, and so on and so forth. But nothing really ever came together. And I think that where we are headed is towards this kind of holistic approach to robo-advice, where you basically will have that the individuals are going to be advised on all aspects of their financial domain, so across the entire balance sheet in a kind of fully automated and integrated way. I know there are companies that have been trying to do it. One of them was Peffin, was a couple of years back, and it never really managed to succeed. But I think that this is one of the bigger questions that we have to kind of think about going forward. So whether we will be able to have kind of separate robo-advisors that are going to be integrated into a holistic one. And then there are another host of kind of very important questions, at least that we're struggling with within the economics and the finance worlds. For example, a question related to democratization, right? So will kind of AI, or like are these kind of robo-advising tools are going to allow to have to democratize access to finance, or are they instead going to exacerbate inequalities. Another kind of important question that people are struggling with is trying to understand what are the systemic implications of having that individuals are going to be robo-advised, in particular if you don't have a lot of competition around robo-advisors, and they may kind of lead all investors to have similar trades or positions, and so potentially even exacerbate shocks. And once again, this is something that I'm going to be talking about today. One of the kind of crucial, I think, kind of barrier to adoption of advice is what people have termed algorithmic aversion. And so today we're going to talk about like how important algorithmic aversion is and whether hybrid robo-advising is a solution. Now, after having like this, couple of minutes of introduction, let me just jump into this paper that is joint work with Tarun Ramadurai, Ansgar Walther from Imperial College, and then Fiona Gregg and Stephen Utkus instead from Vanguard. Now, what is the motivation for this work is that we know that algorithms are ubiquitous. They have, once again, the potential of bringing massive benefits to household markets, but that the potential, one of the kind of potential limit to the scalability of all this innovation is that individuals may not trust these algorithms. We know that algorithmic aversion is real. It has been kind of repeatedly documented in lab experiments. For example, Dietforst et al. In 2015, but there's really little consensus as to what are the psychological underpinnings of algorithmic aversions. So the question, the reason why we started this project is really we were trying to understand whether there's going to be like some natural limits to algorithmic adoptions that are really driven by human preferences or beliefs. Okay, so what we're going to be doing in this paper is we're going to try to decompose all the different components of risk aversion, and we're going to quantify their importance using this kind of hybrid robo-advisor setting that it is kind of Vanguard's personal advisory services, which is the largest hybrid robo-advisor in the world. Now, just in a nutshell, in case you plan on kind of stop listening. So what we do is we study what drives algorithmic aversion. We're going to have first a theoretical framework. This is going to be a framework where we have a preference and belief-based aversion. Then we're going to use a structural estimation to estimate the various components. And this is going to be kind of using Robo-advised data. Now, what do I mean by a model of preference and belief-based algorithmic aversion? What we're going to do is having a model where investors are using a robo-advisor. The robo-advisor has uncertain performance, and there is this kind of three flavors of algorithmic aversion. We call the first disutility. You can think of disutility really as this unwillingness of individuals to kind of interact with the robo-advisor. The other two components are what we call uncertainty and pessimism. Uncertainty is simply just going to be how uncertain individuals are with respect to the quality of the decisions that the robot makes. And pessimism is just going to be the expected quality of the advice. Now, we're going to be developing this theoretical model. Then we're going to take it to the data, and we're going to be using this hybrid robo-advisor setting. Now, as I will say, I will kind of explain in a minute, what happens is that our robo-advisor, our individuals not only are allocated, have their portfolio allocated using an algorithm, but they have that they're also allocated randomly to human advisors that have varying quality. And we're going to be using exactly this kind of random assignment to causally estimate the importance of the human component in hybrid robo-advisors. Now, in reduced form estimates, we're going to show you that high type human advice reduces quit rate by as much as 20%. We're also going to show you that the value of human advice is particularly important in turbulent times. And then we're going to kind of take and look at the empirical estimates through the theoretical models. We're going to show you that ongoing disutility, so this kind of preference or like disutility from interacting with the robo-advisors is much more important compared to this belief channel. And then we're also going to show you that human advice reduces kind of uncertainty regarding how the algorithm operates by as much as 90%. And finally, we're going to be using investors' logins, client advisor interactions, and as well as exit interviews to get and nail and try to nail what is the economic mechanisms that is driving our results. Okay, now let me just start with this kind of a general model of automation adoption. This is a simplified model. I have a more kind of a model with more bells and whistles in the appendix, but I don't have time to go through it. But I think that this general model is going to be giving you exactly the flavor of what we're doing and why we're doing it and modeling it this way. Now, the way the model works is as follows. You have investors that are indexed by I, and the moment on period 1, individuals are born robo-advised. Okay, so the only choice that investors have is that they can choose how many periods to use it, right? And at period capital T, the world ends and they're going to have to quit robo-advice no matter what. Okay, so investors decide endogenously at the time at which they want to quit. The moment they quit robo-advice, they're not allowed to re-enter. And the quality of the service, we're going to be denoting it by theta, and it's going to be unknown to the investors. Now, the moment they start with their robo-advice, the moment that they are born robo-advice, investors not only have their portfolio allocation allocated using this algorithm, but they also allocate it to advisors or experts. So this advisor is going to have two roles. First, they're going to be affecting the client's utility from consuming the service. Effectively, you can think of it as trying to the kind of behavioral coaching that financial advisors do, and the kind of these experts are also going to affect the beliefs of the client. So they're going to affect the expected quality as well as the precision of regarding the quality that the investors have at the time of sign up. Okay, so after the first period where the investor is randomly allocated to a advisor of a different type, you're going to have that investors are going to learn from the performance of the robo-advice. So they're going to see the output of the robo-advice that is going to be the kind of combination of this quality parameter plus some noise. And then at any point in time, the beliefs are going to be updated using Bayes rules. So you have that effectively the beliefs at every point in time are going to be updated using the Kalman filter. So the beliefs parameters, coefficients at each point in time are just going to satisfy the Kalman filtering, standard Kalman filtering equation. Now, this is how the investors kind of forms the beliefs regarding the quality of the robo-advisor. Now, what the decision of the investor is whether quit robo-advisor or stay within the service. So the Bellman equation for the investor's problem is going to be that the value that the investor has is going to be at each point in time is going to be either the instantaneous utility U from being robo-advised plus the kind of the client's expected continuation from being enrolled in the service up to T+1. And if instead the investor decides to exit robo-advice, we normalize the outside utility to 0. Okay, so at every point in time, you're going to have that the investors are going to quit on a given date. If and only if you have that the utility plus this continuation value, the option of continuing staying with robo-advice is smaller than 0. Now, of course, this means that if you have two investors that are signed up, that sign up at the same point in time, and they have exactly the same advisor, they should make exactly the same decision. Now, in order to avoid that, what we do is introduce what we call an implementation error side. That is going to be effectively this kind of idiosyncratic implementation error that is going to affect each individual. And that's going to be something that is just going to give us cross-sectional heterogeneity in the quitting decisions across individuals that are assigned to the same advisor, but have that are assigned to the same advisor and sign up at the very same time. Okay, so at every point in time, you're going to have that this is going to be the optimal decision. The investor is going to quit if the instantaneous utility plus the continuation value is going to be smaller than 0. Now, ideally, so what we're going to be doing in the next iteration of the paper is to estimate all the parameters from simulated dynamics and take it exactly to the data. In this case, I'm going to have a kind of a little bit more of a less ambitious exercise. We're going to be we're going to kind of simplify even more the model. We're going to have a 3-period model. So a kind of a capital T is going to be equal to 2. So this is actually going to allow us to clarify a lot in terms of the parameter identification when it comes to taking the model to the data. So the investor is going to be signing up at time 0, and then at time 2, the world is going to end. So the only decision that investor has is to whether to quit or not at time 1. Now, this is going to be just depending on the instantaneous utility the investor has from staying robo-advised. It's going to be a function of the expected quality of the robo-advice and this psi parameter, which is nothing else but this kind of random shock. Now, this is if I kind of take what the belief at time 1 are going to be and express them as the prior plus the kind of the performance that the investor observes at time 1, I can rewrite this expression on as kind of this slightly kind of uglier expression, but that kind of at least gives kind of relates everything to the prior beliefs and the performance of the robo-advisor. Now, one thing that we can do now is introducing this kind of phi parameter that is should be just interpreted as this critical value of for quality that makes the investors indifferent between quitting and continuing, and you can really interpret this as the disutility of participation when the investor is matched with an expert J. And this allows us to rewrite the expression I had on the previous slide in this much nicer way, where I basically have that the quitting condition for the advisor is going to for the client is going to depend on something that is not dependent on the performance of the robo-advisor, and then something that is instead dependent on the robo-advisor. The first part, the one that does not depend on the robo-advisor, is we're going to call the quiz. We're going to call it the baseline quit rate. This is kind of depends on 2 parameters. First is or 2 features. Like first, the disutility from participation. So this phi parameter. So the more you are kind of unhappy to deal with a robo-advisor, the more you're going to tend to quit robo-advice. And then you're also going to have that the prior beliefs are going to play a role. So you have that the higher is the quality you think that the robots has at the time of sign up, the less likely you're going to be to quit. And of course, the kind of what you have is that this tau are just going to be kind of which are also going to be kind of related to the sensitivity, are simply going to have are going to be such that the sensitivity to performance, for example, it's just going to be dependent on the precision of the performance signal compared to the precision of your prior. Okay, now this is going to be kind of the ultimate equation that we're going to be estimating using our data. So kind of try to remember this, but I'm going to come back to it when when it's going to be the right time. Now, what we're going to do is we're going to take this kind of predictions of the model and we're going to estimate it on data. So instead of working at the individual advisor level, we're going to be grouping our advisors into high quality, low quality. So high retention, low retention. We're going to estimate that using historical performance. And then we're going to be estimating these preferences and belief parameters separately for those clients that are randomly assigned to high retention advisors and to those clients that are assigned to low retention advisors. Now, of course, in order to interpret causally these coefficients, we need to have that the assignment of each client to the financial advisors are going to be independent of all the shocks, so it will be as good as quasi-random. And also we're going to have to be kind of careful and make sure that the advisor type is not going to be mechanically related to the client's attrition rate. And we're going to be, I'm going to be kind of very careful about this. We're going to work with a so-called leave one out estimator, which is very standard in this kind of literatures. Now, let me show you the data we're going to be working with. Now, these are going to be data from Vanguard. These are data from Vanguard's Robo-advisors. Once again, it's called Personal Advisory Services. And let me show you just broadly speaking, what kind of investors we're dealing with. Okay, so we have 55,000 individuals in our sample. We have that the average age is 64 years old. 60% of the people are male, and investors have been with Vanguard for approximately 14 years before signing up for this robo-advisory services. Now, compared to many other robo-advisors that you see there out there, like Wealth from Betterment, Vanguard's investors are much wealthier. So the average wealth or the average kind of account size is almost $800,000. This is and this is kind of after being advised, the number of assets they hold is 8, and mainly because they are kind of index mutual funds. And most of them, 97% of the products that these investors have are Vanguard products, right? So the moment they're robo-advised, the robo-advisor puts these investors into Vanguard products. What kind of products are they? Well, you can see it here in panel C. You have that 95% of these investors' wealth is in mutual funds. 1% is in cash, less than 1% in ETF, 1.4% in stocks, and nothing in bonds. Now, in terms of given that the vast majority of the wealth is in mutual funds, let me give you a sense of what kind of mutual funds people are getting their wealth allocated to. Most of them are index funds that charge 7 to 9 basis points per year in fees and have a turnover ratio of 26%. Now, if you were to compare the performance of robo-advised and self-directed investors, you will notice two things. So this is kind of the annualized average monthly performance. So you see that once they are robo-advised, individuals do significantly better, and it's not going to be something that we're going to care too much about in this paper, but I think it's a fact that I think it's important to stress. Now, one thing that it's going to be important for the exercise we're going to do is that and this is, we're using data from 2015 to 2018. But back then, the robo-advising service that Vanguard used to provide was relatively simplistic. So investors were assigned to 5 glide paths, but truthfully, 96% of investors were assigned to 2 glide paths, and you actually had the performance across different clients that are assigned to different advisors was not very dissimilar. So effectively, what I'm trying to say is that once they were advised, these individuals kind of were homogeneously having a performance that was related to how much they were exposed to the market. But individual advisors were not having a big say in affecting the portfolio allocation. In fact, they had very little impact on that. Now, For those investors that have more than $500,000 in assets under management, you have that they're assigned to a dedicated advisor, as I was mentioning before, and then that's why we model that in the theoretical framework we have. Now, of course, trying to understand what is a good advisor, what is a bad advisor, is complicated, and of course we could use surveys and so on and so forth, but we've decided to go from to resort to a revealed preference approach, where we basically are just measuring advisor type using this leave one out estimator. So we're going to be computing the retention rate of each advisor. So the retention rate of advisor J and client I is going to be simply the ratio of clients assigned to advisor J that do not quit, excluding from the computations client I, so that we don't have any mechanical relation, and also the date at which client I quits, because we want to take care of potential cross-sectional correlations in attrition across individuals in our samples. But of course, we can kind of construct this measure of advisor quality in different ways. For example, we can split the data set in half and compute on one half of the clients this advisor quality and use it on the other ones. And nothing really changes. We can have different specification for controlling for cross-sectional correlation and risk, and nothing really changes. Now, one thing that I need to do is convince you that there is random allocation of investors to advisors. And the way we know that this is the case is because of the institutional feature as to how investors are allocated to advisors. Now, if you were to sign up for the services during the onboarding process, the clients would be asked for their characteristics, risk aversion, investment horizons, and so on and so forth. The Robo-advisor generates a financial plan, but in order to complete the sign-up, the investors have to meet with an advisor. And these advisors, the way they do it is they kind of give to they write into the system what is their availability, and then there is a scheduling system that tracks advisors' availability. And the idea is that all advisors have the same same target of number of clients, and usually the advisor managers are the one that are determining how many new clients advisors are allowed to onboard every week. And so the assumption we make is that the investor's assignment to advisors is going to be quasi-random, conditional on the factors driving onboarding, which is basically conditioning on how much at capacity these advisors are. And so we validate these results by doing the following. So we take this investor's characteristics and we kind of compute the characteristics of the investors that are assigned to high retention advisors and those that are assigned to low retention advisors. And across many characteristics, they're virtually indistinguishable, right? For example, if I think about the portfolio location, you're going to see that the individuals that are assigned to high retention advisors have $946,000 in assets under management, and the one for assigned to low retention have 993, but the difference is not statistically significant. In terms of, for example, the number of assets at the time of signing up, they have 10.7 against 11.4. So also these are not significant. So for the most part, even if I compute the returns of the clients that are assigned to high retention advisors and those that are assigned to low retention advisors, they are almost identical to each other. The ones that are where I see some differences are the age, where you have that low retention clients are assigned to low retention advisors tend to be a little bit older. By a little bit, I mean just 1 year older. And there is also, they tend to have like they are 4%. They have they are, instead of having 57% male, they tend to be 61% male. So slightly kind of representation of male across the ones that are assigned to low retention advisors. Now, but for the most part, we argue that the type of investors assigned to high and low retention advisors are very similar. Now, the second thing that I need to show you is that it is not the case that high retention advisors are systematically given more clients, which is exactly what you would expect to do if kind of the company was optimizing across the dimension. How do we do it? We show it in two ways. So on the left-hand side here, what I'm showing is I'm taking a cross-sectional, every period I divide in every period I have, or every month, I take all advisors and I group them on the basis of how many clients they have. And then I compute here how many new clients that are added every month. So you'll see one thing. You'll see that there is, at least at the beginning, so those clients, those advisors that are starting out, they actually are not given that many clients every month. They're not adding to their portfolio many clients every month. This is just because they're still in the training period. And but then what happens is that the more advisors tend to be more and more at capacity, the more they do not add more clients every month. So what happens is that these are the net clients added every month, which is like the ones that they add compared minus the one that they lose. So they tend to have that they stay put and they do not kind of increase their kind of portfolio clients every period. Now, if I focus on the number of clients added every month, not the net ones, but just the one added, and I kind of compute the results for high retention and low retention advisors, what you'll see is that they are kind of virtually indistinguishable. So you have that irrespective of whether you are a high retention advisor or low retention advisors, you're going to be allocated new clients in exactly the same way. The only exception is the first group. So the ones that have the investors, the advisors that are just starting out, what you see as minor difference. But we argue that this is probably due to some random noise. Okay. Now, after kind of convincing you, hopefully, that there is kind of this quasi-random assignment of clients to advisor, then we can start taking kind of seriously these estimates as causal estimates, the ones that I'm going to show you in a couple of minutes. So I'm going to start by showing you non-parametric survival estimates. So what are we doing here? We're taking advisors, or we compute advisors retention using this leave one out estimator, and then we're going to split clients into two groups. Those that have are assigned to what we call type 0 advisors, which are going to be the low quality advisors. These are the ones that have retention below the median. And then type 1 advisors are going to be the advisors that have leave one out retention rates above the median. And we're going to take all investors signing up for PAS, and then what we're going to do is very simple survival estimates, right? So we're going to do Kaplan-Meier estimates for those that are randomly assigned to kind of a low retention advisors, and those that are assigned instead to high retention advisors. And this is what we get. So in red, I have the clients assigned to low retention advisors. So this is the survival rate they have up to 3 years. So you can see that those clients that are assigned to low retention advisors, you have that approximately 87% of them are still enrolled in Robo-advice after 3 years. If I instead work with those advisors that are those clients that are assigned to high retention advisors, you have instead the proportion, the survival is much higher, right? You have 91% of the clients stay within the service. Now, you remember that I had this kind of the first kind of the first group, the ones that kind of the advisor with the fewest number of clients, that's where kind of my random assignment was breaking down. So I repeat the estimates excluding those advisors, and I show you that nothing really changes. Now, if I use a Cox proportional hazard model, I find that you know, type 1 human advisors, so high retention advisors, kind of are associated with 25% lower hazard. Now, the second set of results that are going to be kind of much closer and are getting us closer to what the model was predicting is to have this dynamic estimates, where I'm going to have panel regressions. On the left-hand side, I'm going to have a dummy for whether an investor I quits in month T, and then I'm going to have a number of dummies. I'm going to have a dummy for whether the market return was negative in the previous month. I'm going to have a dummy for whether the investor is assigned to a high retention advisor, and I'm going to have the interaction between the two. Okay, so if I estimate these results and focus only on the first column because the other ones are just for robustness, what you'll have is that approximately you have that 0.3% or 0.36% of the clients quit every month. You tend to have that in bad markets, this increases by almost 30%, 40%. So this is after kind of bad market conditions, you tend to have that clients quit more. Now, those clients that are assigned to high retention advisors tend to have a quit rate that is lower, so 8 basis point lower, and you tend to have that also the interaction between bad market and type 1 advisor is statistically significant. What is this telling you? It's telling you that this kind of high retention advisors are particularly good at retaining customers after kind of bad market conditions, where when I say bad market conditions is period where the market had negative returns. Now, visualizing this coefficients is relatively complicated, so let me just plot them for you. What you'll see here is that I have on the left-hand side good market conditions. On the right-hand side, I have poor market conditions. You see that high retention advisors have pretty much the same kind of attrition across the two market conditions. On the other hand, you have that the low retention advisors not only have higher a higher attrition rate of their customers in good times, but they disproportionately increase, they lose more customers in bad times. Now, after having these estimates, we can go back to our original predictions of the model. If you remember, we had two quantities that we wanted to estimate. One was the baseline quit rate, and the second was the sensitivity to performance. Now, in terms of the baseline quit rate, what we obtain here is that high type advisors are reducing the baseline quit rate by as much as 23%. If I compare the sensitivity to the performance, which is nothing else but how much the quit rate changes in bad times compared to good times, what you'll see is that for the investors that are assigned to kind of low retention advisors, you're going to have that this is going to be much, much larger. So you actually have that high type advisors reduce the sensitivity to performance by as much as 90%. Now, one thing that we can do, where I think is kind of very interesting, is that we can try to see whether the sensitivity to bad and good market, but the sensitivity of bad market performance vary with tenure. Why do we want to do this? Well, we want to do it because if you remember, we have that our model has this kind of belief parameters, and we have this preferences parameters. The phi was this kind of disutility from interacting with the algorithm. Instead, you had that the M was the prior belief regarding the quality. But of course, once you get in and work with the long tenure clients, what you'll get is that you should expect that the prior beliefs have now converged to the kind of the real quality of the advisor, of the algorithm, and so you can actually kind of interpret the baseline quit rate of the long tenure advisor as to estimate purely the fixed cost of the disutility from interacting with the algorithm. So up to now, what I showed you is a couple of things. So I showed you that human advisors are very important in kind of affecting the quit rate of investors that are robo-advised. I show you that they reduce uncertainty regarding the quality of the robo-advisor. I also showed you that in many cases, what the main channel is not so much that of a kind of belief, but that of a preference for robo-advice. Is that what I'm trying to say is that kind of the human advisors are the ones that reduce the discomfort of individuals from interacting or having a portfolio managed by an algorithm. But one thing that we can do is to get deeper into the mechanism. Now, what we're going to be doing, and in order to do this, is we're going to be using and try to understand this by exploiting client meetings information. Right now, every time a client and advisors have meet, this information is recorded, and this information is stored. And so we access this information, and what we're doing here is to we compute for those clients that are assigned to high retention advisors and those that are assigned low retention advisors, how much time per year do they spend with their advisors? And you will notice the following. You have that high retention advisors spend more time with their clients compared to low retention advisors. This is if I consider the minutes they talk to each other every year, but also if I consider the number of appointments that each client has per year. So all this is to say that high retention advisors spend more time with their clients, which is kind of consistent with them explaining more thoroughly how the algorithm works. But we can get deeper into this. Now, one thing that we can do is that in the data we have, we can see whether it is the meeting was scheduled by the client or scheduled by the advisor. So we can kind of see whether it is really the client that is reaching out to the advisor, or is the advisor that manages the clients by kind of keeping them engaged with it. And that's what we're doing here. We kind of conditioning on the left-hand side. I'm working with advisor schedule meetings, and the right-hand side client schedule meetings. You'll notice two things, that the majority of the meetings are scheduled by the advisors, and the vast majority of the difference is really led by advisor schedule meeting compared to client schedule meeting. You tend to have the client schedule meeting seem to be hovering around 45 minutes a year across both high retention and low retention advisors. Third, what we can do is try and understand whether it is the effect is driven by recurring meeting or non-recurring meeting. What do I mean by this? So whenever you have a kind of this hybrid robo-advisor structure, what people do is they tend to have quarterly, semi-annual, and annual check-ins. And what we can do is kind of condition on the type of meeting. So we can, on the left-hand side, we focus on the non-recurring meeting. On the right-hand side, we focus on the recurring meeting. And what you'll notice is that for the most part, you tend to have that the big difference between the high retention, low retention advisor in terms of meeting with the clients, it's coming from scheduling non-recurring meeting. So it is not really the case that so what it seems to be the case is that all advisors are really doing what is required of them. So what Vanguard kind of prescribes them to do, which is kind of meeting on a regular basis with the clients, but the ones that go beyond the basic advisor duties are the ones that tend to kind of retain more customers. Now, I know that I'm quickly running out of time, so let me just give me another 1 or 2 minutes. The second thing we do in order to try to see whether kind of what is the channels through which advisors can reduce or human advisor can reduce this kind of algorithmic aversion is by working with investors' attention or investors' login. So we see how many minutes investors spend on their on the robo-advising website. And the striking thing about this is that those investors that are assigned to high retention advisors, they spend less time on the platform compared to those that are assigned to low retention advisors. And the difference is quite sizable, right? So we go from 480 minutes a year to 540 minutes a year. And this is if we focus on the time spent on the website. But if instead we kind of work and look at the time spent on the app, then there is no different. So what seems to be, at least the way we interpret these results, is to say that clients assigned to low retention advisors spend more time on the platform, consistent with the idea that the advisors are not giving them all the information they need, and so they spend time trying to understand what the algorithm is doing and how it's managing their portfolio. Now, finally, we can work with also the exit interview with that the clients respond to when they quit Robo-advice. So we call the investors quitting decision. So we can take all the investors and that have quit and see why they quit. And if you look at here, so here I'm taking the two most important, the highest most common reasons for quitting Robo-advice, which is that the clients wants to self-manage and the clients disagrees with the investment policy. So what seems to be the case is that clients assigned to low retention advisors quit disproportionately more because they feel they can manage the investment by themselves and they do not appreciate the service. And on the other hand, you tend to have that those high retention advisors are the one that kind of disproportionately quit more. The clients that are sent to high retention advisors disproportionately quit more, mainly because of cost reasons. And so this is once again consistent with the idea that the advisors for this investors, they're not doing a very good job at explaining what the algorithm does and how it operates. Okay, I think I'm almost out of time, so let me just conclude. We present a model of algorithm aversion. It features learning about the algorithm ability, and it also has this ongoing disutility from using the algorithmic solution. We map this model into this real-world setting using data from Vanguard's personal advisory services. We find that algorithmic aversion can be reduced by human advisors. High type or high retention advisors tend to retain more customers in turbulent times, and uncertainty and the disutility channels of algorithmic aversions are structurally more important compared to the the belief channel instead. Okay, well, thank you so much for your attention. Looking forward to the questions.